Hey there. So what we've done in class so far has always involved a constant acceleration, but believe it or not, sometimes objects' accelerations can in fact change. Crazy, right? So here's an example of exactly that. A subatomic particle follows a path of motion modeled by the equation x of t equals 5t cubed plus 2t, where t is the time in seconds and x is the position in meters. And we want to know how fast this particle is going to be moving after 2.3 seconds have passed, and what is that particle's acceleration at 2.3 seconds. So I'm going to start with velocity. Given the equation of the particle's position at any given moment in time, I can take a simple derivative to find the velocity function with respect to time. This derivative, thankfully, isn't all that complicated to take, so I'll end up with a velocity function of 15t squared plus 2. Now the problem asked for the velocity at 2.3 seconds. So plugging in 2.3 for my time value, I end up calculating a velocity of 81.35 meters per second. And now I can do the same thing over here with acceleration. I already know the velocity function, and I also know that acceleration, as a function of time, is simply the derivative of the velocity function with respect to time. Again, it's a pretty simple derivative to take, and so ultimately I end up with an acceleration function of 30 times t. But it didn't want to know what the acceleration function was. It wanted to know what is the acceleration at 2.3 seconds. So I'll just use this exact same function, but plug in 2.3 wherever I see a t, and solve it out. And I end up with an acceleration of 69 meters per second squared.